Okay, students, now we are going to complete the isomerism. Okay, this is very important video for those who have examination on specially isomerism topic. In this topic, I am going to cover all traps. Okay, most of the students are having overconfidence that whatever we have learned from the books already we have understood and that theory is sufficient. Okay, but when they come into the questions pattern, so there are some lot of misunderstanding where the people are misunderstanding and where the people have done mistakes in their past, where you should not do. Only definition and example are not sufficient until unless where you have to concentrate, where you have to make a bold step, and where you have to use the short tricks. I am going to give you the short tricks, ready-made answers. Directly you can substitute and get the answer. Okay. So I hope you will continue till the last. In the last, I have given you some model questions so that you should be adopted to the current pattern of the question. I think you will all will start this video with a like and share it to your all friends who are worried about their chemistry subject, especially organic. Okay. In this session, we are going to complete the isomerism right from the basic. So isomerism, first of all, it is more found in the two types of compound, in the organic and in inorganic also. In the inorganic, you will find in the coordination compound. Basically, what is isomerism? Okay, what is isomerism? That I am going to tell you. A same molecular formula. What will be there? Molecular formula will be same. Compounds having same molecular formula, but having different either structural formula or spatial arrangement. Either this should be different or this should be different. Then they are called as a isomers, and the property of such molecule to exhibit them is called as a isomerism. Okay, isomerism is a property. Isomers are compounds. So a compound, more than one compound will have some common molecular formula, but there will be something different. Either structure will be different, even structure may be same, but space, in three-dimensional space, arrangement can be different. Okay, so that's why isomers are divided into further two types. If their structure itself is different, then they are called as a structural isomerism. They are called as what? Structural isomerism, or sometimes to make it hi-fi question, it is also called as a constitutional isomerism. But there is no difference, only word difference is there, but meaning wise both are same. Constitutional isomerism or structural isomerism, if they differ in the space, arrangement in the space, what is that space, that we will come to know through this one. Okay, so but basically most of the questions will be focused on the structural isomerism only. Okay, but if they differ in the structure of the carbon chain, structure of the molecule, then it is structural isomers. And if their structure is same, only space arrangement is different, they are called as a stereoisomerism. Stereoisomerism is spatial, and structural difference will be in the structural isomerism. Okay, so further they are divided into so many types. These are all we are going to discuss with some good examples so that your concept can be clear. The beauty of this topic is it is easy to understand but very difficult to apply, and lot of confusion will be there until unless those questions you already do it in the practice session, then only you will get idea of the approach. Okay, definition by hearting and writing example is not a very important thing, it is easy thing. So because of that, most of the students feels that isomerism is a easy topic. I have done all definitions and I can write isomers. No, it is not that. Okay. So where the examiners is going to trap you with the words or with what misconcept will make you attempt the wrong answer, that I am going to highlight in the explanation. So in the structure, if the skeletal chain means main chain. So this is the carbon. Actually, carbon chain is called, only carbon containing is called as a skeleton. Like our body contains skeleton of the bones. So here the hydrocarbon skeleton is made up of the carbon. And like we have the tissues over the bones. Here these are embedded with the hydrogen. Okay. So our tissues fat is hydrogen for the hydrocarbon. Our calcium made bones are the carbons for the hydrocarbon or organic compounds. Okay. So this itself will be different. This itself will be different. Then they are called as a chain isomerism. Okay. Then position of something. What are those? There are three types of position changes may be there. They are called as a position isomer. But some functional groups are there that are examples with general formula I am going to give you. So if you by heart them, if you write and practice them, that is more than sufficient to attempt any question of the functional isomerism. Okay. Then after that, metamerism. Metamerism is applicable only for the polyvalent functional group. Then ring chain isomerism is not applicable everywhere. Where it is applicable, how you have to find out, that also we will do. And tautomerism. Okay. And apart from this, this tautomerism is very important topic. So let us give the separate lecture for this tautomerism. Okay. So we will try to finish off all regarding up to here. Okay. And somewhat about here we will give a good idea so that your score will be improved by at least uh, 30 to 40%. Suppose if you are at the 60%, then you can get at least after this course or after this lecture, you will be adding 30% to your score. Okay. So let's start with one by one slide. So stereoisomerism, conformational isomerism will be with respect to the rotation with respect to the carbon. So like each carbon is attached with one carbon and three groups. So this rotation will give you the conformational isomerism. And three-dimensional space above the plane, below the plane, on the plane, then they are called as a configurational isomerism. Now we talk about with respect to double bond, then it is called as a cis and trans isomerism. Configuration is different with respect to double bond. Like these two are the double bond. If same group is on the same side of the double bond, then it is called cis. It is opposite, then it is called as a trans. And optical isomerism means there should be a chiral center. What center? Chiral. Chiral center is a carbon. Actually, chiral center is simple carbon. But what is the speciality of it? As carbon is a tetravalent. Tetravalent means valence is how much? 4. So all 4 groups attached to this carbon must be different. If it is G1, then it should not be G1, then it should be G2, then G3, then it will be G4. So if all 4 groups are different, then there it is called as a chiral center. Then that chiral center will produce isomers. Those are called as a enantiomers, and the property of showing the enantiomers is called as a enantiomerism. Okay. Enantiomerism, optical isomerism is a property, and examples will be isomers. Okay. So this is all about the introduction about the isomerism. Now let's go to the in detail about one by one with the lively examples. Okay, first, as I told you, we will be discussing in detail about each and everything. Chain isomerism. Okay, so chain isomerism arises due to differences in everywhere. You will be highlighted, you will be very particular about what is the difference. Difference in arrangement of the carbon chain. That carbon chain must be about the word root carbon chain. Word root carbon chain, or it is also called as, see, I told you, nuclear or skeletal isomerism. Okay, so the carbon chain we are talking about, that must be of the main chain. That must be about what? Main chain. Okay, if you take side chain, then it will be something else. Okay, so this is was few of the students are having wrong concept, but you should not have. So don't forget, skeletal chain of main chain must be different. Okay, so next, as an example, if I give you immediately, then it is going to be very effective. Okay, so the chain isomerism is found compounds containing more than 3 carbon atoms. There was a question, which of the following cannot show the chain isomerism? Okay, so if you go for the definition and example, that will not be possible. So chain isomerism will be shown from the butane only, not below the butane. Propane cannot show the chain isomerism. Ethane cannot show the chain isomerism, and methane cannot show the chain isomerism. Okay, so let us take butane. So here skeletal chain or main chain contains how many carbon atom? Its word root is but. But shows that it contains 4 carbon atoms. Okay. See here, the main chain contains only 3 carbon. But if I write the molecular formula, both have 4 carbons and hydrogens. Actually, this is a print mistake. It is CH2. It will be C4. H will be how much? 10. Okay, C4H10. Both have the same molecular formula, but differing in the word root. Probe. Okay, here what is the word root? Probe. Here word root is but. Skeletal chain contained is different. Here skeletal chain contains 4 carbon. Here skeletal chain contains 3 carbon. Now this will be side chain. Okay, so that's why I specially mentioned here. Okay, so that is the difference between only definition or book reading and going through the explanation. Okay, so this is about the chain isomerism. Now let's see the next slide. Okay, now here these are the short tricks. Okay, very important short tricks, so that definitely direct marks you will get. Okay, so people are struggling in the examination and not able to attempt the many questions in the examination because they start counting then and there in the examination. Okay, so like butane, just now I have told you, n butane and uh, 2-methyl propane. So those are the two isomers. You can never make more than 2 isomers for the butane. Okay. Same way for 5 carbon atoms. If they are how many carbon atoms? 5 carbon atom. Maximum number of, and one more thing, these are only chain isomer. Okay. So if they ask number of chain isomers of pentane, you can blindly write 5, sorry 3. Okay, so like that, these are all written and made as a shortcut so that you can save up time in the isomerism. You can invest in the other questions so that you can score more marks. Okay, so C7, these are 9. This C8, that is octane. Then 18, okay, 9, 35, and 10. There is no regular variation. It is not like that. If I add 1, you will get here. If I add 1, then it is see here. The difference is of 2. And here difference is of 4. Here difference of 9. Here difference of again 17. Like that, there is a no regular variation. So you have to make all possible isomers, then only you will come to know. So better thing is you can remember this, so you save time without losing the accuracy. Okay, now let's see the next slide. Okay, next is about the positional isomerism. Next is about position isomerism. As I told you, In the positional isomerism, there will be position of three things. Position isomerism will be differing in three things. What is that? Position of a substituent, or position of a multiple bond, or position of a functional group. Okay, so that means for position isomerism is further we can subdivide into three parts. Okay, either position of a substituent. Substituent is like halogen. Okay, and alkyl group. These are the substituent. Nitro group, like that. I am going to take one more wonderful example from the aromatic compounds. Okay, so their position will be changing. Like if I write as a 2-chloro, 3-chloro, so chlorine position will be changing. Okay, multiple bond, but 1 in, but 2 in, or prop 1, hex 1 in, hex 3 in, like that, or alcohol 2-ol, 3-ol. So like this, compounds will have position isomerism. Okay, now first let us take open chain compounds with mono functional group. Mono means how many? One. Okay, group of substituent, minimum of 3 carbon atoms are required. So these are very important. You will not come to know from the definition. Okay, if they have only functional group, one functional group, then minimum how many carbon atoms are required for positional isomerism? 3 carbon. Suppose if 2 carbon are there, 2 functional group are there, then it is possible. Both OH, for example, I am telling you, both OH can be on one carbon, or both OH can be on the two separate carbon. These are the two position isomers. Okay, this is ethane 1,2,1,1 diol. Here it will be ethane 1,2-diol. So position of the functional group is changing. But if only one thing is there, so if suppose only one functional group is there, okay, then here numbering will be starting from here. So then it will be ethane 1-ol also. Then we will start numbering from here. This is also will be ethane 1-ol. So this type of position isomerism is possible. Position isomerism is possible only if 3 carbon, at least 3 carbon are required. If they contain more carbon, then it is very good. Okay, so like propane, here this is attached on the first carbon itself, therefore it will be 1 propanol. Here it is available on the second carbon, 2 propanol. So position of, this is an example of where position of functional group is changing. Okay, same thing can happen with the double bond or triple bond. Same thing can happen with the halogen, alkyl group, nitro group also. Okay, now we are going to take one wonderful example. So let's see the next slide. Okay, this is a aromatic compound basically. So in aromatic compound, without this, okay, without this, if I don't consider this, then they are called as a mono substituted benzene. Okay, what it is called as? Mono substituted benzene. And this very famous compound, very important compound, it is called as a toluene. Okay, TOLUENE. Now in the toluene there are three types of active site. How many types of active sites? Three types. Okay, so people will say three types, but here I am writing five. So that is the magic, word magic. If question is about the number of active sites, then answer will be 5. And types of active site, answer will be 3. Okay, so this position is called as a ortho. This position also called ortho. This position is called as meta. This position is called as meta. Just opposite to it, it is called as a para. Okay, so para, ortho, meta. So you should not confuse with this series. First will be ortho, second will be meta, third will be para. Okay, so right from the substitute where it is attached. Okay, so then the technique, memory technique. What technique? Memory technique is to remember this. Memory technique, you can say memory trick. Okay, Om Parameshwara. Om Parameshwara means O means ortho, M means meta, P means Parameshwara, para. Okay. So here, see, this with respect to this, immediately after this it is having. Therefore, it is called as a O-chloro, orthochlorotoluene. This is ortho, this is meta. So with respect to methyl group, it is at the meta position. Therefore, it is called as a metachlorotoluene. With respect to methyl group, ortho, meta, para, just opposite to it. Therefore, it is called as a p-chlorotoluene. Full form is parachlorotoluene. So these three are considered as what? Position isomers. Okay, and these are not monofunctional group or mono substituted. These are which substituted? Di-substituted. Okay, di-substituted benzene. Understood? And people are making one silly blunder mistake. See, suppose if I write here, this is, they will write one chlorobenzene. Okay. Now if I write here as here, then they will start writing 2-chlorobenzene. No, this one it is same. Just I have twisted this like this. Okay. So this is also 1-chlorobenzene. This is also 1-chlorobenzene, or simply you can say 1-chlorobenzene. Once it was given optionally, intentionally they gave orthochlorobenzene. No, it is not ortho. Until unless there is one group over here, we cannot say it is ortho. Ortho, meta, para will arise only after one group is substituted. Without one group, we cannot blindly say that bottom part is always para. It is not like that. Okay. This is not always para. This will be para only when one group is attached here. Okay. So then only this will be ortho, this will be meta, this will be para. Suppose if I erase this. Okay. If I erase this group and I will attach something over here. Suppose I will attach something over here. Now this will be ortho, this will be ortho. This will be meta, this will be meta. This will be para. So there is no fixed that bottom will always be para. Okay. You should remember with respect to the first group. Immediately on the adjacent side will be ortho. Next will be meta. Opposite side will be para. So that is the best method to remember the position isomers. Okay. So very important for the both IP board exams as well as for the competitive examination. It is a must and should topic. Okay. Now let's see the next slide. Functional isomerism. Here I am going to give you list like as I given you in the number of chain isomers. Okay. Because after going through the discussion with the students after coming out from the examination, what problem they felt in the examination. Okay, then these notes are made to avoid the same problem faced by your old seniors. That I don't want that you should feel. Okay, so functional isomerism, if you make a ready-made notes which are full-fledged with the current pattern of question, then it will be easy. Okay, now functional isomerism, the chemistry is whatever it is in the name, the same thing will be in the topic also. Functional isomerism. So difference will be in the functional group. Okay. See here, if I write their molecular formula, both are having 2 carbons, both are having 6 hydrogens, both are having 1 oxygen. But when I write them like this, CH3O, CH3, this functional group will be ether. Okay, so the functional group here it is ether. But if I write the same carbon, same hydrogen like this, the functional group is now becoming as a alcohol. Functional group we became as alcohol. So that is the difference between the same molecular formula but different functional group. But it cannot happen with some other. With this molecular formula, I cannot write aldehyde, I cannot write ketone, I cannot write carboxylic acid. So with each and every molecular formula, if you are prepared, Acha, this type of question comes. Like here, we can write as a Cn, and H6 can be written as 2n plus 2 and oxygen 1. So if anything which matches this molecular formula will show functional isomerism. One will be with respect to alcohol, another will be with respect to ether. Okay, so that is called as a functional isomerism. Like this examples and list I am going to give you now. Okay, see functional isomerism, again they are further examples. Alcohols can show functional isomerism only with ethers, no other functional group. People think that with one oxygen I can make aldehyde, but you will feel a problem of hydrogen there. Okay, aldehyde, ketone, and unsaturated alcohol is okay. That means one double bond must be there, and somewhere one OH must be there. Okay, so that is called as a unsaturated alcohol. Is it understood? So unsaturated is because of the double bond, alcohol is because of the OH. So they can show functional isomerism with ketone, they can show functional isomerism with aldehyde, even aldehyde ketone also functional isomers. They both have the same molecular formula. Okay. Next is carboxylic acid and ester. See here, if I write RCOOH, this is carboxylic acid. R dash COO R dash R double dash. Then it will be esters. Okay. Cyanides CN. NC will be isocyanide. Okay. Next, these are actually earlier they are called as isocyanide. Nowadays the name after IUPAC took over the responsibility of the naming. Then it is changed as a, now isocyanide is termed as isonitrile. Okay. So, but problem with the student is IUPAC rule changed it rule that you will now onwards call the isonitrile. But examiners don't change their syllabus. Still, they are giving isocyanates also. So, as a student, you should study this one also and this one also. Okay. Cyanide is called as a nitrile. Isocyanide is called as a isonitrile. Okay. Next, nitroalkanes, NO2 group is there. Okay. And ONO, if it is there, then nitrites. Okay. So these are the some pairs of functional group which they themselves can show. Like carboxylic acid, we cannot write its isomer as a ketone. There will be some difference in the molecular formula. Okay. I think it is clear to you. So next, some more functional group also I am dictating or I am giving you list. Alka, diene and alkyne. Di means two, ene means double bond. See, here one place it is double bond, another place double bond. That's why it is called as a alka diene. Either two double bonds is equal to one, what one? One triple bond. Okay. Next, primary, secondary, and tertiary amines. All of them have same molecular formula. See, this is the nitrogen. Okay. On this nitrogen, only one alkyl group is there. What is there? Only one alkyl group is there. That's why it is called as a primary. What it is called as? Primary. So if I take this nitrogen, one methyl group is on one side and ethyl group is on the other side. Two alkyl groups are there. Therefore, it is called as a 2 degree, or it is also called as a secondary. Okay. See here on all the three sides are methyl group. Then this is called as a 3 degree. 3 degree is also called as tertiary. What it is called as? Tertiary. 3 degree or tertiary. Is it understood? Next, glucose and fructose are very famous example. Glucose C6H12O6 only. Fructose also C6H12O6 only. Okay. because one will have aldehyde, another will have the ketone. Okay, so it is ketose. Actually, fructose is called as a ketose. Glucose is called as a aldose. Okay, that too you will study in the biomolecule chapter separately, including the structure and all in the biomolecules. In which molecules? There is a chapter called as biomolecule. There you will study separately. Okay. Now let's see the next chart. Then comes about the metamerism. What I told you, they are the polyvalent. They must have polyvalent functional group. Okay. Polyvalent means valency must be more than one. I will take some examples. You can identify them. Suppose OH. So OH can form only one bond. Therefore, it is called as a monovalent. What it is called as? Monovalent. But if I write ether, here also alkyl group is possible. Here also this is a divalent. Okay. So when it is a function group can form two or more than two bonds, then it is called as a polyvalent. What it is called as? Polyvalent. So divalent also comes under the polyvalent only. Okay, so that means ethers are eligible to form metamerism because it is divalent. Like carboxylic acid, COH, only one line is there, so it cannot. It cannot because it is monovalent. But if I say ester, see here also it can form bond, here also it can form bond. So this can show metamerism. Okay. So any compound having polyvalent, so that means valency must be two or more than two. Okay. So list I am giving you here itself: ether, thioether. Thioether means only simple. In place of oxygen, it will be sulfur. Ketone, secondary, tertiary amine, ester, acid anhydrides. Acid anhydride will be like this. This is called as acid anhydride. Okay. Secondary and tertiary amides. So these are the metamers. What these are? These are metamers. Okay. Now let us see the next one. So examples with the salt examples. Okay. So if I take C5H10O, what? C5H10O. So it is ready to form how many metamers? Three metamers. See, what is metamer? This is a function group. Okay. So on this function group, in this structure, we have two carbons and two carbon. Okay. So but same thing when it is written like this. Okay. So one side we have two, here it was two carbon, but now it is one carbon, and here it was two carbon, but now they have how many carbon? Three carbon. These two are isomers. So people strange that they will start comparing. They will ask, sir, how they are different, sir? 2 equal to 2, sir. Okay. I am not saying these are isomer. I am saying these two are isomers. So compare these two. 2 is not equal to 3. 2 is not equal to 1. So these two are the metamers. Similarly, you can compare here. And one more thing. Here it is 1, no problem. But here it is ethyl, on that propyl is there. So therefore, these two are the metamers. These two also metamers. So C5H10 have our one of our previous student lost his mark because he forgot to think in this direction. He wrote these two and it was integer question and lost this mark. Okay. So number of metamers are not 2, it is 3. Same way C4H10O. This will also will be 3. Okay. This is what same. This is of the ketone and this is of the what ether. Okay. Similar only thing in place of CO it is oxygen is written. Is that understood? Okay, up to here it is clear. Now let's start with the ring chain isomerism. What is the next topic? Ring chain isomerism. And there are certain frame of condition for showing the ring chain isomerism. Okay. If one isomer has open chain and another isomer have cyclic structure, then such isomer, it is just like a chain isomerism is only, but chain isomerism will be between the open chains, but ring chain isomerism will be one will be C. Here it is a open chain, there is no connection between the bond between the first carbon and last carbon. Okay, but here first carbon is attached with last carbon also. So this is a cyclic. One isomer have cyclic structure, another isomer have open chain structure. So such isomers are called as a ring chain isomerism. Okay. Next, propane 2-ol. So this is a open chain. This is a open chain. But this is cyclic ether. What it is called as? Cyclic ether. It is also called as oxetane. What it is called as? Oxetane. Oxetane. So these are the few examples of the ring chain isomerism. Ring chain isomerism. Okay, here are some model questions related to the isomerism. What is the question will not mention that what is isomer. What is the relation between the following? That means relation you will say which isomers. Okay. First one is butene and cyclobutane. Okay. So butene will be like this CH3 single bond CH2 sorry. The double bond will be here. CH3 CH double bond CH, then it is CH3. Okay, butene and cyclobutene will be like this. See, first of all, the very important thing you should make sure is their molecular formula must be same. Here you will find C4. Both places you will find C4 and H8. Here also C4H8, here also C4H8. So butene, cyclobutene, both have same molecular formula. But what is the difference between them? What is the relation or what isomers they are called? Question is, I think it is understood. As here one is having open chain, another is having cyclic chain. So they are called as ring chain isomerism. Ring chain isomerism. Okay. Now let's see about the next question. Here the structure is given which isomers they are. Okay. So let's see who will give the correct answer. As most of the people given this as a chain isomerism. Okay, this is a previous examination question. It got the record wrong answer. Okay, they thought that here 4 carbons are there, here 5 carbons are there. Skeletal chain is different, therefore it will be a chain isomerism. But answer is they are not isomers at all. They are identical. What they are? They are identical. Okay, because you can take chain like this. So this will be pentane, this is also pentane. So they are not isomers at all. Okay, so don't make the surprising questions wrong. So this was a surprising question and maximum number of wrong attempts was made. Okay, now let's see the next question here. What is a functional group? Here it is ketone. Okay, and here if it is CH, so then it is aldehyde. Okay, so aldehyde and ketone both are what different? Functional groups are different, therefore they are counted as functional isomers. What they are counted as? Functional isomers. Okay, so let us this is about the functional isomer. Okay, Like this twist will be there in your examination. So use my shortcuts given by me and don't get in any traps questions like this. And I hope you will decrease the negative and automatically you will increase the positive and score will be up. Okay.